Hello, my name is Brian Wargo, and I'd like to welcome everyone to the 4th Annual Freedom Area High School Science Conference. Of course, this year will be a little bit different with the coronavirus, and we have a theme this year that says, Living in a Post-Truth Era. We'll talk about that. The first example I want to give is this beautiful pangolin. Is it a picture, or is it a depiction of something that occurs in nature? We have this artistic expression here, albeit digital, could be drawn by hand, we really don't know. The science behind it, though, makes it possible. One of the things that we are going to be talking about today is that tension between art and science. While they go together, there's always tension. If we look at the artist's depiction of the coronavirus, it's a magnificent looking piece that we have here. We've got a lipid and a protein, and then on top of this we have other proteins that our receptors go haywire when they encounter. But this is a horrific disease, and yet this depiction of the coronavirus is actually beautiful. So we have that tension once again. We also have that in our daily lives. At this point, you have a businessman and you have a doctor, and they're fighting over the art of persuasion. Who should we listen to? In the background we have a doctor. In the back we also have a politician. We have Secret Service. We have governors. And all of those individuals are trying to get our attention. So how do we make the decisions? For instance, if we look at the number of corona cases, and this is about a month old, you can see the United States has by far the most cases, and we have quite a few deaths. I think we've actually surpassed the other countries. But here's one of the problems. How reliable is our data? If it's not reliable, this is just an artistic expression of numbers. And there's a difference. So when we go through our long-term projects, we have to think, do we have the appropriate balance of art and science? Now I want to talk a little bit about what science is really about. And the goal of science is to produce explanations. And they should be empirically based. So in other words, we should have some data to back that up. Theoretically consistent. In other words, if we have objects and we know gravity pulls them down, that would be something that we would assume. And then we have to have facts. And facts can be a little bit tricky here. Facts are observations that are reliable measures of reality. Now, in this post-truth era, we might say we have alternate facts. We have to be very careful with that. There is a bit of artistry there. But like a basic fact is, it is a fact that water freezes at 0 degrees, standard temperature and pressure. That means any observer can get this value. We can all look at ice, we can look at their thermometer, we can all say that says 0 degrees, and we see the formation of ice. We should all be able to agree on that particular observation and say it's a fact that whenever we hit 0 degrees, water freezes. And then we want to, of course, strengthen that. We should have a mechanism on why that explanation is valid. And these should be natural and not supernatural, whimsical, or just personal. And they should be based on scientific theory, such as kinetic molecular theory, where molecules are bouncing around, and as they get warmer, they bounce more, and they expand, and they have a greater volume, which would cause the liquid, in this case mercury or alcohol, in this glass tube to go up. So there's a mechanism for that. One of the things that we make a mistake about with science is that science is not truth. And a lot of people think if a scientist speaks, we should instantly accept what they say. And that's just not appropriate. Nor is it to simply ignore science. There are other domains that make the claim of giving truth. We have ancient text, and many of those profess truth. We might have some sales pitch that will tell us how to get rich, and of course there's always the health fads. We should be very skeptical of those. So if science is not truth, we should say it is the pursuit of truth, but it's not truth. And here's how I like to define science. It's the systematic evaluation of evidence and theory filtered through the social practices of scientific critique. That's why we're gathering here today for that scientific critique, which is a social process. And critique is the creative solutions to new and old problems. So creative scientists find ways of not only testing what is already known, but also ways of finding and creating new ways of explaining things. Some of our long terms will find new and creative ways of dealing with old problems. If science is about giving us explanations, we have to understand the power of explanations and their limitations. For instance, explanations get modified. Here's a great picture of Charles Darwin, and he had to modify his explanations as more and more data came about. So, a nice way to think of science is the pursuit of making what is already known better. That's why it's not truth. If we already had truth, there'd be no way to improve upon it. Sometimes we have to replace an old idea that can no longer withstand the scrutiny of the scientific community, of knowledgeable critiquers, which we have alumni here. We have other people that have done long-term projects. They are knowledgeable critiquers. And Darwin, when he came with his explanation of speciation, he needed the world to be very, very old. And the ancient way of knowing things, archaic way, was the earth was very young, 6,000 or 10,000 years old. He needs his to be much, much, much older. But there was a problem. Because back in 1859, when he came up and he finally published this, we have to go back a few years, one of the great scientists, Lord Kelvin, was using a thermodynamics model of the earth and how it should cool, and said it should be maybe 25 million years old. That's a problem for Darwin. Life starting and evolving to the number of species that we have now, it just would not have enough time in 25 million years. And going against one of the premier scientists of the time gave Darwin pause. Thankfully, we had Madame Curie, and these are some of her original texts. And notice they're not written on a computer, they're handwritten, and they're still valuable today. They're wonderful. And she explained how the earth can appear to be young but be very, very old through radioactivity. So explanations can help lead us to truthful statements, but not truth. Do you have to be a Madame Curie, Charles Darwin, or Lord Kelvin to do science? Probably not. However, if you are a genius, it might be easier for you. This is the educational testing service that gives us the SAT and GRE and TOEFL and other tests. And I just took this from the tab, and it says, what is the average IQ of your major? And from testing, they're able to collect this data. And they would put physics and astronomy at the highest end for an average of 133. If you buy into the model of IQ. There are serious problems with that model, but it's fun to play with here. But you should note that we have math, engineering, lots of science, computer information, civil engineering. Then we could start back up here, more and more science. We even go into the social sciences, such as psychology. And then we have education, elementary education, social work. And so these are above average IQs. But it certainly doesn't hurt if you want to go into science and have a high IQ. But let's not be dissuaded. If we look at SATs and we look at the ASVAB, these are two ways of doing what I like to call our quasi-IQ tests. Even though IQ tests have kind of fallen out of fashion, for good reason, we still are using them in some way. And you can see there's a pretty good correlation. And depending on what tests you're taking, they correlate. But other tests, not so much. But here's what we do know. We know there's something that's called the Flynn Effect. And that means over the last 100 years, as we've industrialized, the average IQ, this is the change in IQ, the number of points, has steadily gone up. Red is America. And notice right after World War II, Asia is going to jump up. We help them, industrialize. And Africa is is working their way up, and as their GDP goes up, we would expect this to end up increasing sharply as they have cognitively distributed systems where there's more time to focus on other things than just, getting through the day, having enough to eat, and so on, where we have schools and science and so on. So we would expect to see that jumping up. Here's something very interesting. The average person from 2012 had an IQ, a higher IQ than 95% of the population about 100 years before that. One of the great things this tells us is our IQ is plastic. It is not set. We can change it. I'm also going to go to pay scale and see how that, quote, IQ test correlates with various occupations. In terms of money, in the end, economics rules quite a bit of our lives. So this is pay scale from 2016. And down here we have 0, 50,000, 100,000, 150,000. These are mean salaries for median years of service in that industry or domain. And you could see this green line kind of cuts down here. And again, engineering, economics, physics, math, and so on, chemistry, and so on. We have biology down here because there's so many biologists. Biology's awesome, we know that. And then even, let's point out psychology again, a social science. And then we can end up, and there's education all the way down here. We don't seem to value education quite as much, monetarily at least. My question is, though, as we've been increasing our IQ, have we peaked? And this is a great depiction of a Stone Age creature dressed in a nice suit, wearing a tie, and he can use tools, and he can communicate, and he can think about what he's doing. Although it makes you wonder if he's thinking right now. Why would I say such a thing? Well, in the post-truth era, we have knowledge claims that are personal, whimsical, and they range from the silly, like the flat earth, which this one it's just silly. The flat earth idea is silly. That doesn't mean we have to be rude about it, but it's not based in any type of reality or data or theoretical models. But some of the others, before we laugh, many of us also fall into some of these nearly plausible but still silly ideas, like detoxing by drinking gallons and gallons of water a day, as if that were good for us. And if you ask most people, they'll agree drinking lots and lots of water, it's good for you. Of course you should drink and flush your body continuously. However, when we look at the data, there's really not a lot of evidence for this. But we go on and on with these things, so sometimes they're more robust than they should be. And then we have those that are outright deadly. Here's a gentleman who is skeptical about the round earth idea, and he's got some money. He's not a rocket scientist, nor an engineer, but he's got a lot of money, and he built himself / bought himself a rocket, and he's going to launch himself up to find out if the earth is truly round or flat. Unfortunately, he could have saved himself a lot of time. We have technologies that will do this for us, such as satellites. Airplanes will do it. And in this particular case, he ended up dying. So sometimes in the post-truth era, we have to be very, very, very careful of what we believe. This particular picture might summarize where we are right now. Got the Statue of Liberty showing our love of democracy as the oceans are rising. And we need science right now more than ever. But here's one of the statistics that should give everyone pause. 81% of Americans cannot name a single living scientist. And according to the occupational employment statistics, there's about 5 million in the United States, depending on how you categorize different occupations. And it's my understanding, I looked this up, there's about 1,700 NFL players. My question to you is, how many can you name? How many NFL players can you name? And then how many scientists can you name? And who do we really need right now? So where are we headed? This is one way of thinking about the direction America's going. We have technology that for whatever reason, we just, really love it, like video games, and we've got this Guitar Hero thing, and if we have an American here, he has a Batman shirt on, because we tend to enjoy fiction more than we like nonfiction. Nonfiction is often described as boring. And many Americans have some bad habits. Most Americans tend to eat too much. We tend not to get enough exercise. And then when we get stressed about things, instead of doing those things that might relieve our stress and make us healthy, we do processes that do damage to us, that really put us in danger. So we're vaping. We stopped smoking for a little while and somehow got convinced that we could do this safely. And of course, that's a flawed idea. And now with COVID, anything that's going to irritate your lungs could be deadly in this case. So we have to be very careful in our lifestyle here. All right, so now let's talk about the overall trends in America with education and science. This is PISA. This is an international test that compares all countries and how we're doing. Here's math, reading, and science. This is high score. This is a lower score. We're almost average with mathematics. Reading, we're just a little bit above that purple, which, are a little bit better than, the average. And yet we spend more money on education than any other country. In science, we're just above average. But there's bad news here. When we look at some of the other tests, and we can see over the years what's happening, our scores were improving until recently. Now they seem to have peaked, and we're starting to wonder if we're going to end up sliding back down. Remember, the other countries are going to be going up as they industrialize. If we start going down, we will lose our competitive edge with science and technology. That's why we're here with long-term projects. They model science and scientific practice authentically. Now, what we mean by this is nearly all the aspects of science, both materially, data collection and protocols and things of that nature, and socially, critique and things of that nature. All of those are represented in our long terms, really important aspects of science. And of course they're difficult. So if you ask any one of the students that's done a long term, are they difficult? They are all going to say, oh yeah, much more difficult than I thought. Are they worth it? Yeah, they really were. It was a lot of work, but it changed how I think. Now ask the world, are you glad that we are training scientists for the future? And I think everyone would say, yes, please train more. We don't want to have another pandemic. And if we do, we certainly don't want to have to go to shaman. We don't want to have to pray our way out of that. We would like to have science that can help us. So what we want to do is thank all of the students that are doing long terms for this particular conference. And we look forward to when these students make the world more knowable. Thank you very much, and I'll be giving some more direction to how the day is going to play out. But thank you very much.